Welcome to Study Loop.
Okay, so we're doing chapter 29, problem 33. So in this problem, we have a circuit with a resistance R, and these two wires are connected by a free-moving metal bar. And this is all in a B field that is pointing into the page. Okay. And it gives us the length of the rod is going to be 0.25 meters. The resistance of the resistor is 6 ohms. The magnitude of the B field is 1.2 Tesla. And what we're asking here is when the current is counterclockwise and at a magnitude of 1.75 amps, we want to figure out how fast this bar is moving in which direction. So what's V? Okay, so we can do this a couple different ways, but the way I propose is doing energy conservation. So the rate and change of work must be equal to the rate and change of thermal power given by this. So if we rearrange this equation, we can solve for V. We're just going to worry about the magnitudes here. So the magnitude of V is given as the magnitude of I times R over L times B. Okay. So since we know all these things, we can easily plug this in. So this is 1.75 times 6 over 0.25 times 1.2. Okay. So this comes out to being 35 meters per second. So now we just got to figure out, is this moving to the left or right? Okay. So if I is counterclockwise, so let's just draw I here. This is I is counterclockwise. We know that. That means the B field induced is out of the page. If the B field induced is out of the page, we can use Lenz's law to go backwards now that the rate of change in magnetic flux, then we already know is going to be greater than 0 because magnetic flux is into the page, but the induced one is out of the page, so it must be into the page and increasing. Okay, so if our flux is increasing and our flux is increasing, but this is just B times A. If B is constant, then A has to be increasing. So V is to the right. 35 meters per second to the right. Awesome, because we're having an increasing flux, so the A has to get bigger, and the area of this must get bigger if V is going to the right. Cool.